Welcome to the next session. We were discussing chapter 5 probability and we were discussing classroom workbook. Let us start the session with classroom workbook. Go through your classroom workbook. Question number 28. Question number 28. Let A1, A2 and so on An be n independent events. We have n independent events with P of Ai equal to 1 minus 1 by alpha power I, where alpha is greater than 1. So what is P of Ai? P of Ai is 1 minus 1 by alpha power I. Here alpha is a number, real number, which is greater than 1. My events are independent events, that is A1, A2 and so on An. All these are independent events. Independent events. So what's the question? This is the data given. The probability that at least one of the event occurs. At least one of the event occurs. Now here you can see what is P of A1 when you replace I by 1 actually. So here actually we have n independent events. P of Ai is this. When I equal to 1 to n, I values are ranging from 1 to n. So P of A1 is 1 minus 1 by alpha. P of A2 equal to 1 minus 1 by alpha square. So and so on. P of An equal to 1 minus 1 by alpha power n. So we need to find probability that at least one of the event occurs. So probability of at least one of the event occurs. So this can be written like this: 1 minus of P of none of the event occurs. Just as a complementary event. Probability of at least one of the event occurs is 1 minus P of none of the event occurs. So therefore this is 1 minus of P of none of the event means their complements. So we can write it as A1 bar intersection A2 bar intersection A3 bar and so on intersection An bar. So bar represents complements. So no event should occur, therefore this must be intersection. And now since all these events are independent events, their complements also become independent events. So when the complements are independent, this intersection becomes multiplication. Therefore 1 minus of P of A1 bar dot P of A2 bar dot P of A3 bar and so on dot P of An bar. Now this is 1 minus of P of A1 is this, but the probability of its complement is 1 minus of this, so we get 1 by alpha. Similarly, this becomes 1 by alpha square. This becomes 1 by alpha cube and so on 1 by alpha power n. So this is 1 minus of 1 by a power m into a power n like this. So you will get alpha power 1 plus 2 plus 3 plus and so on plus n. So therefore this is 1 minus of 1 by alpha power sum of first n natural numbers is n into n plus 1 divided by 2. So the answer is option C. The result is option C. Let me explain once again. Here all the events are given as independent events. The probability of each of the event Ai is 1 minus 1 power alpha I, where alpha is greater than 1. So if the events are independent, their complements also become independent events. Now all these are probabilities of events: P of A1, P of A2 and so on, P of An. So we need to find out this probability of at least one of the event. So probability of at least one event is 1 minus none of the event occurs. Complement event. So this is the complement of this event. So no event should occur. So A1 should not occur and A2 should not occur and A3 should not occur and so on An should not occur. So and is there, therefore the symbol we use is intersection. So for complements we use bar. Now if the events are independent, their complements also become independent. Therefore for independent events this intersection becomes dot. Now P of A1 bar dot P of A2 bar and so on P of n bar. So therefore when you simplify these probabilities, we get 1 minus 1 power alpha 1 by alpha power n into n plus 1 by 2. So therefore this is option C is right answer. Let us go through question number 29. In an examination, there are 80 questions, each having 4 choices. only one is correct and other three are wrong. A student is awarded 1 mark for each correct answer and minus 0.25 for each wrong answer. If a student takes the answer of each question randomly, then the expected value of his or her total marks in the examination is. So how many questions are there? 80 questions. For right answer, student will get 1 mark. For wrong answer, student will get minus 0.25 negative mark. In one of the previous sessions, we handled one question based on this. Okay. Now it's similar to like this. See, when you go through options, interestingly, they are like this: minus 15, 0, 5, 20. Now let us see, suppose student is ticking the answer randomly. Suppose assume that I am a student. If I take all answers, if I take all questions rightly, then you may ask me, sir, what happens if a student takes all questions answers very right correctly? Then 80 into 1, 80 marks, but 80 is not there in options. Suppose if you think in the negative way, if all options, if you go in the wrong attempt way, then 80 into minus 0.25, okay, you'll get minus 20. Minus 20 is not there. So therefore probability is, it is uncertain. It is uncertain. You may ask me, if I attempt all questions wrongly, then you will get 80 into minus 1 by 4, you will get minus 20, but minus 20 is not there in options. If you attempt all questions correctly, you will get 80 into 1, 80 marks, but 80 is not there in options. If you take, for example, 40 right answers, so 40 into 1, 40. If you answer 40 wrong, then 40 into minus 1 by 4, so that is minus 10. So 40 plus minus 10 is 30, even 30 is not there. So like this, you can have various possibilities, but this purely depends on expectations, okay? So PDFs are not certain candidate, they are uncertain, right? Now let us see. Suppose X represents a random variable which represents marks of a student for attempting single question. So which represents marks of a student for attempting, marks of one student for attempting single question. So X is a random variable which represents marks of a single student for attempting single question. Therefore the PDF will be like this. X values now 1 minus 0.25, because X represents marks, student will get 1 mark if he or she attempts correctly. So only one is correct. So the required probability is 4 options are there, one has to be right. So one option out of 4. So therefore they will get minus 0.25 if they attempt any one of the 3 wrong options. Therefore 3 out of 4. This is the PDF of the random variable X. Now let us find expectation. So therefore in this case expectation is, this is a discrete random variable because X is taking 2 sample points. So this is 1 into 1 by 4 plus minus 0.25 into 3 by 4. So therefore this is 1 by 4 minus 3 by 16. So therefore this is LCM 16, 4 minus 3, this is 1 by 16. But this is expected marks for attempting single question by single student. But how many questions were there? 80 questions. Of course, they one student only, but number of questions is 80. Therefore, the total expected marks equal to 80 into 1 by 16, and this value is 5. Therefore, option C is right answer. A single die is thrown 2 times. What is the probability that the sum is neither 8 nor 9? Sum should not be 8 as well as 9. Single die is thrown 2 times. So you will get 36 sample points. 6 square, you get 36 sample points. So we need to find probability that the sum is neither 8 nor 9. So actually sum is 8 and sum equal to 9. Sum should not be 8, actually sum should not be 9. Okay, so apply the complement of this. So sum should not be 8, sum should not be 9. So you can take sum equal to 8, or actually this is sum equal to 8 and sum equal to 9. Or in simple words you can do like this. So I should not have some value 8 as well as some value 9. But let us see in how many ways you get some value 8. In how many ways the sum value is 9. Let us see sum value 8. The sample points are like this: 4, 4, 5, 3, 3, 5, 6, 2, 2, 6. Now when you take sum 9, the sample points will be like this: 4, 5, 5, 4, 6, 3, 3, 6. So these are the various cases where sum is either 8 or 9. Sum is either 8 or 9. So what is sum? Sum is either 8 or 9. How many cases? 9 cases. 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore the required probability is is 1 minus of. So here how many sample points? 9 sample points. 9 out of 36. So this is 1 minus 1 by 4. Therefore this is 3 by 4. So the answer is D. Next question number 31. If X is a continuous random variable whose PDF is given by f of x equal to k into 5x minus 2x square for 0 less than or equal to x less than or equal to 2, 0 elsewhere or otherwise, then what is P of x greater than 1? P of x greater than 1 is required. Now here P of x greater than 1 means basically integral 1 to upper limit is 2 only. So f of x dx. So therefore this is integral 1 to 2. F of x is k times 5x minus 2x square dx. So therefore we can evaluate this definite integral only when k value is known. Now let us see how to get the value of k. Since it is a PDF, when you integrate this function between the limits 0 to 2, it gives 1. So integral 0 to 2 f of x dx equal to 1. This implies integral 0 to 2 k times 5x minus 2x square dx equal to 1. So this implies k times integral 5x is 5x square by 2 minus 2x cube by 3, limits are from 0 to 2 equal to 1. This implies k times, replace x by 2, 2 square 4, this is 10, 2 cube 8, 8 to 16. So k into 10 minus 16 by 3 equal to 1. Therefore this is k into 14 by 3 equal to 1. Therefore the value of k is 3 by 14. But be careful, 3 by 14 is option A, that is only k value, but you must find this value. So substitute k value 3 by 14 and do the integration, you get the answer. Therefore P of x greater than 1 equal to, here k value is 3 by 14. So 3 by 14 into integral 1 to 2 5x minus 2x square dx. So therefore this is 3 by 14 into, this is 5x square by 2 minus 2x cube by 3, limits are from 1 to 2. So this is 3 by 14 into, when you replace upper limits, the value becomes 14 by 3. So this is 14 by 3 minus, replace x by lower limit, 5 by 2 minus 2 by 3. So therefore this is 3 by 14 into 14 by 3, 14 plus 2. So this is 16 by 3 minus 5 by 2. So 3 by 14 into LCM is 6, 32 minus 15. So therefore this is 17 2. So this is 17 by 28. So therefore the final answer is D. Suppose P of x equal to m times e power minus 2 mod x plus n times e power minus 3 mod x is the PDF for the real random variable x over the entire x-axis. M and n are both positive real numbers. Then the equation relating m and n is, Now this is my PDF which is running on entire x-axis. So limits are ranging from minus infinity to plus infinity. Then they are asking what is the relation connecting m and n. M and n are some constants. Now let us see here, since it is a valid PDF, when you integrate this, so integral minus infinity to plus infinity, p of x dx equal to 1. So this implies integral minus infinity to plus infinity m times e power minus 2 mod x plus n times e power minus 3 mod x dx equal to 1. Now this is an even function. Because mod x is there, since it is an even function, this becomes 2 times integral 0 to infinity. On positive side, mod x becomes x. So this is m times e power minus 2x plus n times e power minus 3x dx equal to 1. So this implies 2 times the integral e power minus 2x is e power minus 2x by minus 2 plus n times its integral is e power minus 3x by minus 3. Limits are from 0 to infinity. So this implies this is 2 times minus m by 2 into e power minus infinity minus n by 3 into e power minus infinity. Apply lower limits, you get minus m by 2 into e power 0 1 plus e power 0 is 1. This is n by minus 3 equal to 1. E power minus infinity means it is 1 by e power infinity. So this is 1 by infinity, but 1 by infinity is 0. So this and this will be 0. This implies 2 times minus of minus plus. So 2 into m by 2 plus n by 3 equal to 1. So this implies m plus 2 by 3 into n equal to 1. So the equation relating m and n is m plus 2 by 3 into n equal to 1. So it is option A. Very simple. Since it is a valid PDF, when you integrate this from minus infinity to plus infinity, the result will be 1. But when you are integrating a function from minus a to plus a, if it is even function, then it becomes 2 times integral 0 to infinity. If it is odd, it will be 0. But here mod x, we have mod x inside the function p of x. So it is an even function because mod of minus x is mod x. So therefore, when you go to positive side limits, mod x becomes x. Now integrate this, you will get m plus 2 by 3 into n equal to 1. So option A is right answer. Now let us discuss question number 33. An examination paper consists of 2 papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. So P of 1 is 0.3. Probability of failing in paper 1 is 0.3. Probability of failing in paper 2 is 0.2. P of 1 is 0.3, P of 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. Already student has failed in paper 2. So in that case, the probability that a student failed in paper 1 is 0.6. That means they gave us P of 1/2 equal to 0.6. Already student is failed in paper 2. In that occasion, what the probability of failing in paper 1 is 0.6. This is conditional probability. Now they were asking the probability of a student failing in both the papers. So we need to find out this. So what is the probability that a student fails in both the papers 1 and 2? Now let us look at this. Here P of 1/2 equal to 0.6. Now this implies P of 1 intersection 2 divided by P of 2 equal to 0.6. Therefore, P of 1 intersection 2 equal to 0.6 into P of 2. But P of 2 is 0.2. So therefore, this is 0.12. This is basically the definition of conditional probability. So 0.12. Option C is right answer. Let's move to question number 34. The random variable x takes on the values 1, 2, 3 with the probabilities like this. The first probability is 2 plus 5p divided by 5. P of 2 is 1 plus 3p by 5. P of 3 is 1.5 plus 2p by 5 respectively. So it is a discrete random variable because the random variable x is taking only 3 values, finitely many. So it's a discrete random variable. Then the values of p and e of x. The values of p and e of x are respectively. Now we need to find this p value. Since it is a discrete random variable, sum of all probabilities sigma I equal to 1 to 3, p of I equal to 1. That is p of 1 plus p of 2 plus p of 3 equal to 1. Sum of all probabilities must be equal to 1. This implies 2 plus 5p by 5 plus 1 plus 3p by 5 plus 1.5 plus 2p by 5 equal to 1. Now this implies denominators are same, add numerators 2 plus 1 plus this. So this is 4.5 plus 5 plus 3 plus 2, 10p equal to 5. So 10p equal to 0.5. Therefore the value of p is 0.05. The value of p is 0.05. Now we have two different options with this p value 0.05. So answer can be either A or C. Answer can be either A or C. Now let us find expectation of x. So here E of x equal to 1 into this plus 2 times this plus 3 into this. So 1 into 2 plus 5p by 5 plus 2 into 1 plus 3p by 5 plus 3 into 1.5 plus 2p by 5. So therefore this is 2 plus 2 plus 4 plus 4.5. So this is 8.5, 5p plus 6p, 11p plus 6p, 17p divided by 5. So this is 8.5 plus 7 into this is 0.05 divided by 5. Therefore the value of this is 0.87. So therefore this is option A is right answer. Just read the question. A fair coin is tossed till a head appears for the first time. The probability that the required number of tosses is odd. Very interesting question. A fair coin is tossed till a head appears for the first time. The probability that the required number of tosses is odd is. That means I toss a coin. If I get first time head, my experiment is over. If I don't get head in the first attempt, then I go for second time. If I get a head in the second toss, first head in the second toss, then I will stop my experiment. Then otherwise I can go for third time toss. So I will keep on continuously tossing a coin. Whenever I get first time heads, I stop the process. Okay. So I keep on toss a coin continuously. Whenever I get first time the head, I stop the process. My job is over. So in that case, I need to get the first head in odd number of tosses. So what is the probability? The probability that the required number of tosses is odd. That means first time I may get first head. Third time I may get first head. Or fifth time I may get first head. Or seventh time I must get first head. Or ninth time I must get first time head. So therefore, in this case, the required probability will be like this. So first time you may get head. So or third time, or fifth time, or seventh time, or ninth time, etc. So many times, infinitely many. So that means I got head in the first attempt only. But I got first head in the third toss. That means first time I got a tail. Second time I got a tail. Third time only I got first head. So actually this is nothing but that tossing a coin these many times. So 3 times I toss a coin. Because in the odd number of tosses, I must get first head. So therefore, do not confuse. Very interesting question. So the required number of tosses must be odd. So first time I got first head. Third time I am getting first head means in the first 2 tosses I am not getting head. That means ultimately I am getting tail. Fifth time, in the fifth toss I am getting first head. That means in first 4 chances I am getting tiles only. Again 7th time. So in first 6 chances, I am getting tile. Similarly, like this. Therefore, one or first time or third time or fifth time or seventh time or ninth time, like this. Therefore, the required probability is, so one time, so the probability is 1 by 2. R means plus. So these are independent events, independent experiment. Probability of getting tile 1 by 2 into 1 by 2 into 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2 plus 1 by 2 times 1 by 2 times 1 by 2 times plus 1 by 2 times 1 by 2 plus and so on. So therefore this is 1 by 2 plus this is 1 by 2 whole cube plus 1 by 2 whole power 5 plus 1 by 2 whole power 7 plus and so on. Now it is an infinite series. Now you can take 1 by 2 common. This is 1 plus 1 by 2 whole square plus 1 by 2 whole power 4 plus 1 by 2 whole power 6 plus and so on. Now this is 1 by 2 into 1 plus this 1 by 2 square means 1 by 4. This 1 by 2 power 4 we can write it as 1 by 4 whole square. This is can be written as 1 by 4 whole cube plus and so on. Now this is a series expansion 1 plus x square plus x cube plus and so on. But what is the value of x? 1 by 4. Now therefore this is the series expansion of 1 minus x whole inverse. So this is 1 by 2 into 1 minus 1 by 4 whole inverse. So therefore this is 1 by 2 into this is 3 by 4 whole inverse. So therefore this is 1 by 2 into 4 by 3. Therefore this is 2 by 3. So option number C is right answer. So very important model from since last 5 years. Many questions were given particularly for electronics and electrical students. So very important model. Okay. So go through this question.